Example 9 looks almost identical to example 8. We've got two complex numbers written in modulus argument form, and we want to multiply them together, z1 times z2. Now, you could think that you could just use this formula straight away, and we know how to use this formula. We would times the moduluses together to get the new modulus of the product, and we would add together the arguments. The problem is, in the formula, we had a plus and a plus. Both of these numbers were written in modulus argument form. In order for a complex number to be in modulus argument form, you need a plus in the middle. The problem here is that we've got a minus on this complex number here. So z2 actually isn't written in modulus argument form. So what we're going to have to do before we use the formula is we're going to have to write z2 in modulus argument form with a plus in the middle. Well, the fact that we're going to use in order to do that is we're going to use the fact that sine of minus theta is equal to minus sine of theta, and that's true for any value of theta. And this is a fact that we're going to use time and time again in further maths when dealing with complex numbers. So that basically means if you've got a minus inside the bracket of a sine, you can take the minus outside of the bracket. So if we have this complex number z2, which is 3 cos of 2 pi over 5 minus I sine of 2 pi over 5, then we're going to use this fact, and actually we can take this minus and put it inside the bracket of sine. So we could write z2 as 3 cos of 2 pi over 5 plus I sine of minus 2 pi over 5. Okay, so that's good because now we've got the plus in front of the I, okay, and we've used that fact there. The problem with this now is that in order to have it in modulus argument form, the two angles need to be the same as each other, theta 1 and theta 1. But here we've got an angle of 2 pi over 5, and here we've got an angle of minus 2 pi over 5. So that's a problem. Well, it's not actually a problem, because another fact that's really useful is the fact that cos of minus theta is the same as cos of theta. So it doesn't make a difference to cos whether the angle is positive or negative. As long as theta is the same, you'll get the same answer for cos. So we can write z2 as 3, and then actually we can write that is exactly the same as cos of minus 2 pi over 5, because they're the same as each other. Check it in your calculator. Okay, so now we've got a complex number, and this is in modulus argument form because we've got a plus in front of the I, and also the two angles are the same as each other. So that's in modulus argument form. So now we're in a position to use this formula. So z1 times z2, we're going to times the moduluses together. So we've got 2 is the modulus of z1 times by 3, so which is 6. And then to get the argument of the product, we need to add together the arguments. So we've got pi over 15 is the argument of z1, and then plus the argument of z2. Now you've got to be really careful. Remember, this is not in modulus argument form. Our argument of z2 is this argument here, minus pi over 5, minus 2 pi over 5. Okay, and we can simplify that to get z1, z2 is equal to 6 cos of minus pi over 3 if you add together those two angles, and then plus I sine of minus pi over 3. Now, we weren't actually asked for that. We were asked for the complex number in this form x plus iy. So we need to simplify this as much as possible. So we need to make it really clear what the real part is and what the imaginary part is. So to do that, we're going to expand the square bracket. So we're going to write that as 6 cos of minus pi over 3 plus 6I sine of minus pi over 3. And then we can just work out what is this value of 6 cos of minus pi over 3. So the real part is 3, that's this part here. And then we're going to have, if we do 6 times sine of minus pi over 3, we get minus 3 root 3. So we've got minus 3 root 3i. So our complex number z1 times z2 can be written as 3 minus 3 root 3i. So this is in real part plus imaginary part form, and this is in modulus argument form.